Unit 3, Lesson 3, Function Junction. Which one doesn't belong? All of them. None of them belong. They each have something about them that's different. But what I want you to notice about these graphs is that when a graph goes off the edge here like this, we're going to go ahead and assume that it goes on forever, like that. Okay, so the first graph, what it has the other one doesn't have is a minimum. Part B has this kind of weird discontinuity to it. C is not a function because an input like 5 has more than one output. D is the only one that's discrete, and E has no minimum. Only has this maximum at the top. So what we did today in this lesson was we learned how to be more efficient, more familiar with the 8 features of functions, and also we looked at some weird cases or cases we haven't dealt with before. So for example, on number 1, it says that it's a discrete function. Well, that means that it instantly jumps from 1 to 2, 2 to 3, 3 to 4, etc. Now, when we list the domain, we list the numbers individually because there are no in-betweens. So these are the 5 things you can have as input. And then for range, we'll do the exact same thing. So 5 and 10 and 40 and 80 and 100. For minimum and maximum, that's still going to be the same. Maximum would be at 5, 160. Minimum would be at 1 and 5. There are no intercepts. Intervals of decrease. We'll still use the interval notation here and go from 5, actually from 1 to 5. And there are no intervals of decrease. So what did we learn here that's new? We learned about discrete functions. How do we say their domains and ranges? How about this one? Well, the domain is the lowest point. The lowest point's over here on the x. The lowest x and the highest x is here. Now that just happens to be the endpoints, but it doesn't have to be the endpoints. The x's, if we list this point here is -8, -3. And this point on the right is 10, 5. So if we just use the x's, it goes from -8 to 10. On the range, it goes from -3 to 5. Maximum just so happens to be the endpoint, 10, 5. Minimum happens to be the endpoint, -8, 3. Intercepts, there is 1, it's right here. That's approximately at 0 and 4.1. And then on the y, there's 1. Let's say that's about -6.2 or 6.3. The increase, remember, if you drive a car on this thing where you're going uphill, that's the increase. So we're going up and up and up and up. Then we hit the highest point, and then we start going down and down and down. And then we go up and up and up again. So increase happens from -8 until, well, let's say approximately on the x, about -1. Now let's join this together with the other increase. Now we've been using the word and, but there is a mathematical symbol. It's something that looks like a big giant U, and that means union. It's how we join together intervals. And that would go from about 7 up till 10. As far as intervals of decrease, there's only one. It's from about that -1 point until, it looks like about 7. So what did we learn here that's new? We learned how to join together two different intervals. We're also getting familiar with how do we find domain and how do we find range. Now, on this graph, we're going to draw the x and y axis. We're going to draw the x and y axis. And a good way to look at what the graph's going to be is to look at a table. So we have maybe 0, 1, 2, -1, -2. 3 to the 0 is 1. 3 to the 1 is 3. 3 to the second is 9. 3 to the -1 is 1/3. Covered this in the last unit. And this is 1/9. So we go to plot those points. 0, 1, 1, 3, 2, 9. That's off the graph. -1, 1/3. And probably -2. So that's so close. Probably can't even see it. And there we go. Now, the domain here is any number. Any number can be taken as the power of 3. Now, there's a couple of different ways to write this. One way to write this is R. That R stands for all real numbers. Or, here's another way. In the interval notation, we can use infinity. That's right. There's a symbol for infinity. It looks like this. There's actually two infinities. There's negative infinity on the left, positive infinity on the right. And also at our endings, instead of using the brackets, we're going to use parentheses because we can't actually get to infinity. Infinity is more of a concept than it is a number. So by putting parentheses, we're saying we're basically just going in the direction of infinity. Now we know it's not a point because of context. It doesn't make sense to say that there's a point out there, negative infinity, positive infinity. The range, now there's a number of different ways I could write that. It doesn't actually get to 0. It gets really, really close, but doesn't touch it. I could say 0 to positive infinity. And then I'd have to use parentheses again because I'm not getting to 0. And infinity's just a concept. Or an easier way to say this might be just to say y is greater than, or, well, not equal to, but just greater than 0. The maximum, there is none. The minimum, there really is none. The intercepts, there's only just this one at 0, 1. It's increasing on the entire interval, entire domain, from negative infinity to positive infinity. There's no decrease. And yeah, it's a function. One input gives you one output. So what did we learn new this time? Well, we learned how to deal with infinity. Number 4, Mark bought a $900 couch. He's going to pay $50 each week. When does he pay it off? See, that's not stated in the problem. So we can figure that out real quick. We can set up an equation, 900 minus $50 per week And when is it going to equal 0? So x will be the number of weeks. If we take away 900, there's 0 there. And negative 50x equals negative 900 divided by negative 50. That's kind of a mess. Let me try that again. And x equals 18. So really, x can't go past 18 because he's already paid off the couch by then. So the story is over. The domain goes from 0 to 18. Oops, let's try that again with the right kind of bracket. Now the range goes from 0 to 900 because he either owes, actually let's do that in numerical order. He either owes nothing on the couch or he owes everything on the couch. So the maximum there was at 0, 900, the point, and the minimum occurs at 18 weeks when he owes nothing. They are both intercepts, so they will be just rewritten here. Interval of increase? No, it's never increasing. He's always paying this off. So there's none here. And for decrease, there is, the entire domain he's decreasing. 0 to 18. It is a function because at any 1 week, he only owes one amount. But it is discrete because once he pays off that $50, it's instantly getting paid off. Now, starting to run out of time in the class at this point. So real briefly on this one, did you notice it goes down here and then it goes up? It is a continuous function defined on the interval from 0 to 6. So that was the domain. And the range went from what we see, it went from -3 up to 20. And that would make 620 the maximum and 1 -3 the minimum. The intercepts are at 0, 2 and 2, 0. Intervals of increase, they went from basically being at 1 until the end and decreased from 0 to 1. So we learned here that a table can be a continuous function if something says it's continuous. And then number 6, we just talked about this discontinuity here. If you want to find the function value at 6, well, which one of these points do you go with? Is the answer up here at 7, or is the answer down here at 4? And the answer is the one at 4, because the dark dot means you're equal there at 4, at 6, 4. The open circle is an inequality. It says anything after 6, and then as you can see, it goes increase for a little bit. Anything above 7. Well, we just looked at the domain and the range here. So the domain, everything is covered from 0 to 20, actually 21. Everything is assigned from 0 to 21. The range, though, the range goes from a minimum down here. It's not at the end point. It's down here at, say, -2.5. That's where the minimum is. And the maximum is at the end point at 10. So the range here goes from, let's see, though that would be -3.5. All the way up to 10. And you'll get better at this the more you do it. We stopped right there in class. We kind of ran out of time. So this is the end of the assignment, and we've kind of done the takeaways as we've gone through it. So we'll see you next time.